So let's take a look at how we'd go about trying to rewrite the merge sort algorithm. As you see, the algorithm is in two functions. One is simply the merge sort, the entry point top level function, which takes a list and it splits it into two parts if it's a large list. Then we recursively sort the left and right parts and then simply we merge them together. So as you see, this function is pretty straightforward. There's nothing much to be done here. This function, on the other hand, the one that actually merges the individually sorted lists, that is something that I believe can be made a little better. So let's simply copy this original code into a new file and go about trying to make it a little more readable. So here's one thing that immediately leaves a bad taste in my mouth, that since we are calling the merge function over here with arguments called left and right, here we are calling them A and B. So let's just simply go ahead and make them left and right so that overall the API is more readable. And therefore this A would be left and this would be right. Now here is where we seem to be adding a little redundancy in the code. We are keeping track of 4 variables which keep on changing as the algorithm progresses. C is the output list. We merge A and B into a list called C, left and right into a list called C, and that's the list that we finally return at the end of the function. And I, J, K are essentially variables that denote the position that you are in each of the left and right parts and the length of the final output list. I believe that out of these 4 variables, we only need to keep track of 3. The length of the output list is something that we don't need to record explicitly in a different variable, and that's because computing the length of a list in Python is a constant time operation. So simply keeping track of a separate variable which records length of a list is a little wasteful. So what we're going to do is, while length of C is less than m plus n, we're going to keep doing something. Now let's see what that is. I here is supposed to be the index that you have popped from the left list. J is supposed to be the index of that you might have taken from the right list. So let's actually make it explicit and call them left pos and right pos. So what that means is you track which position you are in the left list and in the right list. So while the length of C is less than the sum of the individual lengths of the two lists, we need to do something. So let's remove this code and see how we can fill it in. Now, one edge condition that we might want to see is what if the left list is completely finished. So we say that if left pos is the same as m, which is the length of the left list, then all we need to do is extend C by whatever's left in the right list. So we just do C dot extend right, and whatever's ahead of right pos, we just extend it. Otherwise, the other symmetrically, the symmetric condition of this is if right pos is equal to n, which means that you've exhausted the right list, then we extend C with whatever's left in the left list. So left pos, colon. Now come the core part, which is that you have to look at the top elements in both lists and pick whichever is the least of them. So we say that if elif right of right pos is less than left of left pos, then we do C dot append of the less of the two, which is right of right pos. And of course, here you have to increment right pos because you're one step ahead now in that right list. Else, simply do the same thing opposite. We'll just copy this and C dot append. This becomes left of left pos, and then we also increment left pos. That's it. That's our code. So yeah, we saved a couple of lines and we also managed to track one variable less, and hopefully the code is a little more readable.